3, 2, 1.
Salutations and welcome to Space Time Continues. My name is Mary Louise Davey. Let's get going to space. So this journey that you and I began a little bit ago, it began on the Earth, but we realized that we needed to become a multi-planet society. So we're like, oh, doomsday and such, so we have to get off of this, right? So last time we looked at space propulsion, but there's so much more, like warp drive, and how NASA's working on a warp drive. Well, they're calling it the M drive, and we'll get to that next show. But this show, before we leave the solar system, I thought we should take a look at some planets that were in our backyard, their differences and what we found out about them, and some really cool plans we have on visiting them and finding out a little bit more. So if you've got nothing else from me, you know that it's important to understand the past in order to understand the present and the future and look forward past that. And speaking of past, way back, before we know about really, the past of the first planet we want to look at just may have been close to ours. Known as Earth's twin, Venus is what we begin with. The planet Venus is a hot, hellish, and volcanic planet. Named for the Roman goddess of love, actually the only planet named after a female, Venus shines the brightest of the 5 planets that were known to the ancient world. Now, ancient astronomers, well, they actually originally thought that there were 2 separate planets, both the evening star, or Vesper, and the morning star. They were similar in size, mass, density, composition, and gravity to Earth, but their similarities end there. Venus is the hottest planet in the solar system. While Venus is not the planet closest to the Sun, Its dense atmosphere traps its heat via runaway greenhouse gases. And that effect, which is similar to what warms the Earth, but it was really, really bad. So the temperatures on Venus are about 870 degrees Fahrenheit, that's 465 Celsius. And it's enough to melt lead, and probes have only been able to survive a few hours before they're destroyed. But it gets worse. Venus's atmosphere is not much better. It consists mainly of carbon dioxide with clouds of sulfuric acid, and trace amounts of water have been detected in the atmosphere. The atmosphere is heavier than that of any other planet, with a surface pressure 90 times that of Earth. Now the surface of Venus is extremely dry. During its evolution, the ultraviolet rays from the sun evaporated water quickly, keeping it in a prolonged molten state. There's no liquid water on its surface today because the scorching heat created by its ozone-filled atmosphere would cause any to boil away. About 2/3 of the Venusian surface is covered with flat, smooth plains that are marred by thousands of volcanoes. Pretty hot, right? Some are active today, ranging from about half a mile to 150 miles, that's 0.8 to 240 kilometers wide, with lava flows carving long, winding canals up to more than 3,000 miles, that's 5,000 kilometers in length, longer than on any other planet. There's even a mountain. Actually, there's 6 mountainous regions. The highest of them is a mountain called Maxwell, 540 miles long, climbing 7 miles high. A day on Venus lasts 116 days, 18 hours, using Earth days, of course. By far the slowest of any of the major planets. Because of this slow spin, the metal core of Venus, well, it's not able to generate a magnetic shield the way that Earth can. Its atmospheric composition by volume is 96.5% carbon dioxide, 3.5% nitrogen, with small amounts of sulfur dioxide, argon, water, and carbon dioxide, helium, and neon. Now, Venus's southern hemisphere, as seen in the ultraviolet, So, what's the history of Venus? Well, remember, often stories exist in the constellations that it was because the people would take off and the captain of the boat might be telling the people under him, okay, well, it looks like Leo, and that's how they learned to remember, because maybe they weren't the most bookish of person, but they'd all know these ways of learning the constellations. So while Venus might have not been a star, it's shown as bright as if it were, often putting actual stars to shame, actually. Back in Mesopotamia, they recognized it as one of the brightest stars in the sky. Actually, I think it's one of the 3 brightest, the Moon, Venus, Jupiter, although I guess you might want to include the Sun in that. But anyway, Venus was known since way back to prehistoric times and had gained an entrenched position in human culture. It's described in Babylonian cuneiformic texts such as the Venus tablet of Amesduqa, which relates observations that possibly date to 1600 BC. The Babylonians named the planet Ishtar, Sumerian Iana, the personification of womanhood and goddess of love. She had a dual role as a goddess of war. So what woman doesn't have a dual role? So she presided over life and death. One of the oldest surviving astronomical documents from the Babylonian library of Ashurbanipal around 1600 BC is a 21-year record of the appearances of Venus. The ancient Sumerians and Babylonians called Venus Dilbat or Dilipat. In Akkadian, it was the special star, the mother god Ishtar. In the Chinese, well, the planet was called Jingdeng, the golden planet of the metal element. In India, Shukragana, the planet Shukra, which is named after a powerful saint, Shukra. Shukra, which is used in Indian Vedic astrology, means clean, pure, or brightness. in Sanskrit, clearness. One of the 9 Navagrana, it is held to affect wealth, pleasure, reproduction. It was a son of Bhrigu, the preceptor of the Daityas, and Guru of the Asuras. The word Sukra is also associated with semen or generation. Move slightly south from China and Venus, and then it's known as Kehora in Indonesian and Malay. Modern Chinese, Japanese, and Korean cultures refer to the planet literally as the metal star. In Mayan astronomy, Venus, considered the most important of the celestial bodies observed by the Mayan, who called it Chakek or Noach, the great star. The Maya monitored its movements of Venus closely and observed it in daytime. The positions of Venus and other planets were thought to influence life on Earth, so the Maya and other ancient Mesoamerican cultures timed wars and other important events based on their observations. In the Dresden Codex, the Mayan included an almanac showing Venus's full cycle in 5 sets of 584 days each, which is approximately 8 years, after which the patterns repeated. Now, since Venus has a synodic period of 583.92 days, they really weren't very far off. The Mayan civilization developed a religious calendar based in part on the motions of the planet and held to the motions of Venus to determine the precipitous time for events such as war, and they named it Zukek, the wasp star. They were aware of the synodic period and could compute it within 100th part of a day. Then there were other cultures and how they saw Venus. Well, the Maasai people, they named the planet Kilekan and have an oral tradition about it called the Orphan Boy. Venus is important in the Australian and Aboriginal cultures, such as the Yoingo people in northern Australia. The Yoingo gathered after sunset to await the rising of Venus, which they called Bonumbr. And as she approaches in the early hours before dawn, she draws behind her a rope of light attached to the earth. And along this rope, with the aid of a richly decorated morning star pole, the people were able to communicate with their dead and loved ones, showing that they still love and remember them. Bonumbr is an important creator spirit in the dreaming and sang much of the country into life. Which brings us right up to today. So let's look at who's been visiting thus far. Well, a number of missions have been at least partially successful at a flyby of Venus, 38 to be exact. Additionally, about 12 or so have tried and, well, not been so successful. The first successful flyby of Venus was performed by NASA's Mariner 2 spacecraft on the 14th of December in 1962, followed by several failed attempts by both the Soviet Union and the US. The first successful landing on the surface was by the Soviet Venera 4 lander, which touched down on the surface on the 18th of October in 1967. This was followed by a number of other spacecraft in the Soviet Venus exploration program, culminating in 2 balloons known as Vegas 1 and Vegas 2 in June of 1985 that flew in the Venusian atmosphere. The most recent spacecraft to visit the planet is the ESA's Venus Express, which has been in orbit around Venus since April 11th in 2006 and is performing scientific analysis and is expected to last until at least December of 2014. So, what cool ideas for visiting Venus and what kind of awesome spacecraft do we have? Well, for the surface of Venus, we have the Venus Land Sailing Rover. Take a look at it there, pretty cool, huh? NASA Glenn has developed some electronics that will continue to function through everything described, that hot, hellish, volcanic planet. Well, these electronic components actually represent a breakthrough in technological capabilities for the high temperatures, as they're being built to operate at incredible ones. I mean, we could use these here on Earth in volcanoes and such where we need to take readings, so this is really cool. Now, thanks to the high cloud levels and thick atmosphere, and they produce a low power density, basically, they know that because we can produce an electrical power on the surface, so they know that a rover for Venus is not beyond the bounds of physics. Therefore, we could survive the furnace of Venus if we can come up with an innovative design and concept for a rover that can move on extremely low power levels. Well, guess what? In order to do this, we have to take advantage of the in situ resources of Venus for mobility. Now, by in situ, and I've explained this before, it's the taking advantage of the resources that are native, that are all around you, okay? So taking advantage of, say, the atmospheric pressure at the surface, because that's almost 100 times greater than that of Earth, right? Well, oddly, even though the winds, like, they're not very strong, they're under 1 meter per second, at Venus pressure, even a low wind speed, you get significant force. Therefore, the concept for this planetary rover is a sail-propelled rover for the surface of Venus. Think of it, a new frontier. We can explore the surface of a new planet thanks to a robotic explorer. Not that we'll want to colonize or set up tents or go on holiday, but remember, they were born our twin. What happened? We need to know. And while land-sailing vehicles can climb hills, it's more difficult for them to operate on a landscape that's densely packed with obstacles, say, on the scale of meters. But in this respect, the surface of Venus actually does us a favor. From the views of Venus that were taken by the Russian Venera probes, the surface of Venus is seen to have a landscape that's kind of flat, with its terrain stretching on the horizon. Rocks appear only on the centimeter scale, and at least in the locations where the Venera probes landed. Ideal for land sailing. Basically, the long and short of it is, first we will analyze the technologies needed for a robotics land sailing vehicle on Venus, and do a top-level analysis, trade study of the rover design, and then next, the NASA Glenn Compass spacecraft design team will be utilized and do a detailed design study of the vehicle and the mission. And think of it, Venus is the epitome of an unexplored planet. We will go where no one has gone before. Of course, we're not talking long term. I mean, we're not ready to launch now. But in 10 years, we could. The idea is sound, technologically credible. It has a sound scientific and engineering basis, and a reasonable implementation path to go from a technological dream to a future engineering reality. So, what planet shall we look at next? The moon's so, how should I say, pedestrian. Actually, we have some really cool things planned for there, but I'm going to do a show in the future just on the moon because of the cool things and the so many areas that I can delve into. But I'll wait till the plans are more settled. So, how about Europa? Europa it is. First we go into the description, then the history, then the missions. Europa's 4.5 billion years old. That's about the same age as Jupiter. No big surprise, since it's found in orbit around the planet Jupiter. Now, while it's 390.4 million miles from us here on Earth, the distance from Jupiter is only about 417,000 miles. It's tidally locked. That means the same side always faces it. While it goes around, it's the same side. Similar to Ganymede, which is another one of Jupiter's moons. There are about 67 moons of Jupiter. A day on Europa lasts approximately 3.5 days. Size-wise, it's a tad smaller than our own moon. So how would it feel on Europa? Well, if you were to look around, you'd see little ridges, a couple of meters high in every direction, cracks that crisscross as far as you could see. They will continue everywhere around the entire moon. And where did those cracks come from? Well, the gravity from Jupiter. It's quite a strong pull on the subsurface ocean, the rise and fall, not to mention the frequent breaks and geysers that extend into space, cause the cracks. of course, I wouldn't be looking out for you if I didn't warn you about the deadly radiation. The planet's magnetosphere rains deadly radiation all over you. But you wouldn't be disappointed in your view of space, of Jupiter. I mean, really cool views from there. So, truth be told, while the radiation might have killed you, you got 6 months to live. I mean, it's not going to kill you immediately. So, lest you think it's a tropical paradise, maybe I should tell you the other part. It's kind of cold. The temperature averages about minus 260 degrees Fahrenheit. That's minus 160 Celsius. That's near the equator. It touts ice quakes, where sometimes giant plumes of water violently shoot up out of the ice. Another problem is you might get hit by a meteor or some particles from space. So, walking on Europa, well, that'd be very similar to walking on our own moon. The gravity is only about 13% of Earth's. The atmosphere is nearly non-existent. Hence, Europa has no clouds, no weather to speak of. If you wanted to go somewhere cool, say local historical sites, visit Chaos Terrain. It's a place where normally flat ice has been fragmented up and broken up into like jumbled rocks. And then there's the icy domes, the moon's depressions, lots of pretty cool stuff. The major visiting location that would be below the ice and in its ocean. And guess what? If you weren't already dying from an unhealthy dose of radiation, once you get below the ice, there's no radiation. The ice blocks it all. So that part's cool, right? So it's actually in the ocean and down actually at the surface that scientists expect to find life, especially if it's theorized that there are cracks in the crust, the mantle, and it allows heat vents. And these seem places that would be most likely for life. So, Europa, what's the history? The history was it was discovered way back in 1610 by Galileo Galilei. At the time, there were only 4 known moons of Europa. And while they were given numbers, this became informally known as Europa after a lover of the Greco-Roman god Jupiter. Europa was a Phoenician princess abducted to Crete by Jupiter. Europa was gathering wildflowers in a seaside meadow when she came upon a beautiful white bull. This bull was uncommonly gentle and did not inspire fear. So, decking its horns with flowers, Europa was at length emboldened to climb upon its back. And whereupon the bull, actually the god Jupiter in disguise, took off at a trot and dove into the sea. Europa was carried off to the island of Crete, where she became the mother of King Minos. Now, if you were to look this up, you might see the god Zeus mentioned in it. Well, that's because Zeus and Jupiter are the same god. The Romans regarded Jupiter as the equivalent of the god Zeus. And in Latin literature and Roman art, the myths and iconography of Zeus are adapted under the name Jupiter, also Jupiter, which is usually thought of to originate as a sky god. His identifying element is a thunderbolt, and his primary sacred animal is the eagle, though he had reigned over all birds. And Zeus was often found as a bird, and namely an owl, and he was also associated with the thunderbolt. So yeah, it actually turned out they're both the same god. So several spacecraft have done flybys of Europa, such as the Pioneers 10 and 11, Voyagers 1 and 2. Back in the 1970s, the Galileo spacecraft did a long-term mission at Jupiter and its moons between 1995 and 2003. And looking forward, both NASA and the European Space Agency have missions planned to Europa and other moons, actually, in the 2030s. So let's have a look at NASA's plan. There is to be a flyby of Europa, and what are those objectives? Pretty simple, basically. The idea is to search for biosignatures and analyze the surface and near-surface signs for life. The next area of interest is to conduct in situ analysis to characterize the composition of non-ice near-subsurface material and determine the proximity of liquid. Now, recently erupted material near the lander's location Well, it's all in situ. And there's that word again, huh? The last goal would be to characterize the surface and subsurface properties and understand what is responsible for shaping them, partially in support of future exploration missions. NASA's upcoming mission to investigate the habitability, however unlikely, unless we were to live, say, under the ocean. Jupiter's icy moon Europa has a formal name. This mission, it's called the Europa Clipper. And the name takes one back to the Clipper ships that sailed across the oceans of Earth in the 19th century. Clipper ships were streamlined, three-masted sailing vessels renowned for their grace and swiftness. They often transported products. Many goods, like tea, were shuttled across the globe. And in the grand tradition of these classic ships, the Europa Clipper spacecraft will sail past Europa at a rapid cadence, as frequently as every 2 weeks, providing many opportunities to investigate the moon up close. The prime mission plan includes 40 to 50 flybys, during which the spacecraft would image the moon's icy surface at high resolution and would investigate its composition and the structure of its interior and icy shell. Robert Pappalardo, Europa Clipper project specialist at NASA's Jet Propulsion Lab in Pasadena, he says that during each orbit, the spacecraft spends only a short time within the challenging radiation. So it speeds past, gathers a huge amount of scientific data, but gets out of there before the radiation can do any damage. Previously, when the mission was still in the conceptual phase, it was sometimes informally called Europa Clipper, but NASA has now adapted that name as the formal title for the mission. This mission is being planned for launch in the 2020s and arriving in the Jupiter system after a journey of several years, and will be manned by the JPL for the agency's Science Mission Directorate in Washington. But wait, there is another mission. In 2016, due to a directive by Congress, NASA's Planetary Science Division began a pre-phase A study to assess the science values and engineering design for a future Europa lander mission. NASA routinely conducts this sort of study. It's known as a Science Definition Team, SDT, reports. And long before the beginning of any mission, in order to gain an understanding of the challenges, feasibility, scientific value of the possible mission, maybe check with the scientists, say, hey, what do you think is important that we have on this? What do you want to know? So scientists are in agreement that the evidence is strong that Europa, which is slightly smaller than Earth's moon, has a global saltwater ocean beneath its icy crust. This ocean has at least twice as much water as Earth's oceans. While recent discoveries have shown that many bodies in the solar system either have subsurface oceans now or may have had them in the past, Europa is one of only 2 places where the ocean is understood to be in contact with a rocky seafloor. The other, of course, being Saturn's moon Enceladus. This rare circumstance makes Europa one of the highest priority targets in the search for present-day life beyond Earth. The SDT was tasked with developing a life detection strategy, a first for NASA. The only mission previously that would have had it was the Mars Viking mission more than 4 decades ago. The report makes recommendations on the number and type of science instruments that would be required to confirm if life signs were present, and samples to be collected from the icy moon's surface. The team also works closely with engineers to design a system capable of landing on a surface about which very little is known. Given that Europa has no atmosphere, the team developed a concept that could deliver its science payload to the icy surface without the benefit of technologies like a heat shield or parachutes. So perhaps next, maybe Saturn's moon Enceladus, as it would be a popular destination for such missions, as it is believed to potentially host extraterrestrial life as well. Our final place to visit this week is Saturn's Titan. Titan is Saturn's largest moon of 53 and second largest in the solar system after Ganymede of Jupiter. It is the only moon in the solar system with clouds and a dense planet-like atmosphere. Scientists believe that conditions on Titan are similar to Earth's earlier years, with one main difference. The Earth is closer to the sun, and so the Earth has always been warmer. And in fact, according to NASA, in many respects, Saturn's largest moon, Titan, is one of the most Earth-like worlds we have found to date. Some basic facts. The diameter of Titan is 3,200 miles or 5,200 kilometers, smaller than Earth, about half the size actually. Also, it's about as large as Mars is. It has a surface temperature of minus 290 Fahrenheit, 179 Celsius, making water hard as rocks and allowing methane to exist in its liquid form. The pressure is about the same as Earth, well, slightly higher, about 1.6 bars. In fact, if we were to arrive on this planet, we would be able to get out of our spacecraft and acclimate to the difference quite easily. Now, a day on Titan is 15 days, 22 hours, and 41 minutes. Titan has polar winds that draw methane and nitrogen charged with interactions with light out along Saturn's magnetic field and out of the atmosphere. A similar process is believed to happen on Earth with our own magnetic field. So what would it be like if we were to, say, walk on Titan? So with an average temperature, as I've said before, of negative 290 Fahrenheit and minus 180 Celsius, it would be a little chilly. Heck, most of Earth's extremophiles would find it cold. Frostbite occurs or begins just below 32 degrees Fahrenheit. So the temperature of Titan, yeah, it would freeze you solid almost instantaneously. But say you wore a spacesuit, which you'd kind of have to. Well, then you might enjoy Titan's beauty. It is the only moon in the solar system that has clouds and a thick planet-like atmosphere. And like Earth, its atmosphere is mostly nitrogen, but it rains gas-like liquids. Not as much of a problem as you would think. I mean, you just have to be careful with your own oxygen. Also, if you did end up introducing oxygen, which is kind of explosive, oxygen, you would have a fire. Well, don't use water to put it out. Because remember, H2O, water, H2O, O, the last part of that oxygen. So then you're going to cause more fire. So, but there are really many cool things to see. Radar images from the Cassini spacecraft revealed that a land of lakes in Titan's northern hemisphere. These lakes are about the size of North America's Great Lakes. Cassini also detected canyon-like structures on the surface of the moon. But back to its lakes. They're mostly methane and ethane, a Texan's dream. So if you happen to have a boat with you, you might have a problem. First, there is the fact that methane is about half the density of water, meaning that you'd have a hard time churning the methane enough to propel the boat. Second problem? No, that's not a problem as much as it is a benefit. You see, because the density is so low, or I mean, so much less on Titan and this fluid, well, mix that with the lower gravity, and you can push yourself about halfway out of the water, kind of like a dolphin. And best of all, Titan's atmospheric pressure is about 60% greater than that of Earth's. So walking on Titan would be roughly the same as walking on the bottom of a swimming pool. And since you're lighter and the air is denser, with large artificial wings, it would be possible to fly. Pretty cool, right? So what about Titan's history? First, to where the name came from. In Greek mythology, the Titans were powerful gods, incredible strength, knowledge of old rituals, magic. Their dwelling place was Mount Others. In Greek culture, they were interpreted as personification of Gaia, that's Earth, and Uranus, the sky. Cronus, one of the Titans, took the rulership of the cosmos from his father Uranus. Actually, he castrated him. And then the 12 Titans took leadership over the earth. You may recall the next generation of gods, that be Zeus and Poseidon and that whole bunch. Well, they took the powers from the Titans after rebelling against Cronus and his followers, and then moved to Mount Olympus. Back to the current world. The name Titan and the names of all 7 satellites of Saturn, and well, that's all that were known at that time, came from John Herschel. He's the son of William Herschel, discoverer of Mimas and Enceladus, in his 1847 publication, Results of Astronomical Observations during the years 1834, 35, 36, 37, 38, at the Cape of Good Hope. He suggested the names of the mythological missions to Titan. You've no doubt heard of Cassini and its awesome flybys of Titan while it executes a gravity slingshot on the way through. It's going through all the rings of Saturn, and then ultimately it's going to go down to its death, but it's going to pick up some cool views of Saturn that nobody's ever gotten to look at. Well, NASA's Cassini spacecraft went by the moon Titan towards the end of its mission, and as I said, using it to slingshot the probe onto the trailblazing trajectory to explore the region between Saturn's hydrogen-helium atmosphere and the planet's famous rings for the first time. Well, during this time, scientists were able to obtain their first glimpse of Titan seas, weather patterns, and rippling sand dunes. Cassini sailed around 608 miles above the moon. The encounter served a dual purpose: gather the mission's final bits of close-up data on Titan and reshape Cassini's orbit to make the first passage inside Saturn's rings. Cassini's scientific sensors gathered more information on Titan's lakes and seas, studied the moon's atmosphere, probed the interaction between Titan's ionosphere and Saturn's magnetic field, and took a sequence of pictures that are beyond anything we've ever had. Cassini spent plenty of time with its 127 flybys of Titan on exploring its lakes, its streams of liquid methane and ethane, while peering through the moon's clouds with radar. So now the scientists have radar images and topographic maps of a quarter of the moon, including many of it, the complex river systems, the liquid-filled depressions fed by rainfall, mountains, craters, sand dunes, all those which resemble those on Earth. Cassini also found that Titan apparently hides an underground ocean of salty liquid water and ammonia. The Cassini project, first conceived in the 1980s, has a cost of nearly $3.3 billion from start to finish. Cassini launched in October 1997 from Cape Canaveral aboard Titan IV rocket, flew by Venus and Jupiter, reached Saturn in July of 2004, becoming the first space probe to slip into orbit there. The orbiter dropped a European probe named Huygens to land on the surface of Titan. The orbiter dropped a European probe named Huygens to land on the surface of Titan, Saturn's largest moon, in January 2005. Since then, Cassini has circled Saturn more than 260 times, collecting detailed imagery of Saturn's atmosphere and mysterious hexagonal polar vortex, explored in its rings in minute detail, observed 49 of Saturn's 62 known moons with close, long-range flybys, both. And then the not-so-long-ago swing by Titan committed Cassini to its fate, and the craft will naturally fall into Saturn in September. So even if it runs out of fuel at this point, its fate is sealed. It's going down regardless. So 10 years ago, the European Huygens probe descended through Titan's atmosphere and became the first ever robotic mission to touch down in a world in the outer solar system. During its daring 2-hour and 27-minute descent through the murky atmosphere of Saturn, its largest moon, the probe revealed an unprecedented view of the alien environment. On landing, Huygens survived an hydrocarbon-rich surface for only 72 minutes before its batteries drained. But the data it transmitted via NASA's Cassini spacecraft was nothing short of revolutionary. Data that continues to be analyzed 10 years after that fateful day. That's January 14th in 2005. Now, here are just a few mind-blowing images from Huygens as it gave us our first intimate look at the solar system's only moon known to possess a thick atmosphere and vast liquid methane-ethane lakes. A world that, like Jupiter's moon Europa, invokes exciting hypotheses of extraterrestrial life. After traveling with the Cassini mission for 7 years during its interplanetary transit from Earth to Saturn orbit, the command was given for the Huygens spaceship to detach from the mothership. And for 21 days, the small disc-like probe was itself cruising towards Titan. And as Huygens ripped through the Titan atmosphere, eventually slowing down enough for its heat shield to drop away and parachutes to deploy, the probe got to work rapidly, photographing its descent and collecting atmospheric data, and showing how the moon's dune-covered surface slowly came to view as Huygens slowly drifted to the surface below. Looking down, Huygens also captured a slowly evolving view of its eventual landing spot. Shown here, a fisheye view of the landscape below starts to detail some of the surface features the probe will be soon analyzing up close. In the run-up to landing day, mission scientists were unsure whether Huygens would land on solid surface or not, or maybe splash down in the methane-ethane puddles or lakes. Well, as it turned out, it splatted down in Titan's alien mud, a mix of small grains of ice and such. Photographs during the descent were gradually shown to us an alien and familiar at the same time landscape. Titan's covered in dunes, as I said before, valleys, lakes, all shaped by erosion, processes we find here on Earth. The valleys are cut by liquid action and the thick atmosphere producing winds and weather systems that form dunes and, fields of these fine hydrocarbon sand. But these Titan weather systems are not driven by an Earth-like water, as the atmosphere is too cold to support water in a liquid form. Other chemicals, such as the methane and the ethane, exist as a liquid, forming their own cycle. Methane rain is now known to fall onto the landscape, creating rivers that erode valleys, form deltas in vast liquid methane and ethane lakes. By landing a probe onto Titan's surface, the joint ESA and NASA mission, the Cassini-Huygens mission, was able to get ground proof of the flyby imaging and radar. And last year, Cassini completed its 100th Titan flyby. So in the 10 years since Huygens landed, planetary scientists have been getting a front row seat of the moon. In 2005, Titan science was as foggy as the moon's atmosphere. So by overlaying ground-based observations with Cassini images, a better interpretation of landscape was found. Pretty cool, right? So what about a Titan-Saturn mission of some sort, system mission, TSSM? Well, it's a joint NSA-ESA proposal for an exploration of Saturn and its icy moon, Titan, Enceladus, following up on some of the complex phenomenon revealed by Cassini, with an estimated cost to NASA of $2.5 billion. That was back in 2007. The TSSM was proposed to launch in 2020, and using gravity assists from Earth and Venus would arrive at the Saturn system in 2029. The 4-year prime mission would include a 2-year Saturn tour and a 2-month Titan aero sampling phase, and then a 20-month Titan orbit phase. In 2009, a mission to Jupiter and its moons was given priority over the TSSM, or Titan Saturn System mission, although the TSSM will continue to be studied for a later launch date, possibly in the 2020s. So detailed assessment reports of the mission elements, as well as specific concept for a lake landing module for Titan's lakes, called Titan Mar Explorer, TIME, the potential of becoming part of the TSSM has been proposed. The mission overview was really kind of awesome. I mean, a balloon is planned to circumnavigate Titan. The TSSM mission consists of an orbiter and then two Titan exploration phases. A hot air balloon, that's Montgolfier type, that will float in Titan's clouds, and a lander that will splash down on one of its methane lakes. Both probes' data are to be relayed to a Titan orbiter. They will be equipped to study Titan's features with instruments for imaging, radar profiling, and surface as well as atmospheric sampling, much more complete than done by the Cassini-Huygens mission. The spacecraft will use several gravity assists, flybys, from other planets to enable it to reach Saturn. The baseline design envisioned by a September 2020 launch and by 4 gravity assist, Earth, Venus, Earth. It will arrive at Saturn 9 years later in October 2029. This is one of the several available Earth to Saturn transfer options from the year 2018 through 2022. Current NASA plans do not give the TSSM a priority, so it's unlikely that any of the proposed launch dates will be met. The Montgolfier, a hot air balloon, would be released on the approach to the first Titan flyby for ballistic entry into Titan's atmosphere. And its first 6-month mission would basically from April 2030 to about October 2030. Based on Cassini-Huygens discoveries, the Montgolfier should be able to circumnavigate Titan at least once during its nominal lifetime, at its deployment latitude of about 20 degrees north, 10 kilometers above the Titan surface. The lake lander for the TSSM, known better as the Titan Mar Explorer, TIME, was originally proposed as a separate scout mission, but eventually might be postponed and then done at the same time. So, due to Titan's haze layer and its distance to the sun, the lander cannot be powered by solar panels, so it would have to rely on the new advanced Stirling radioisotope generator, that's the ASRG, which is a prototype meant to provide availability of long-lived power supplies for landed networks and other planetary missions. The lander will be targeted to Ligeia Mar, that's a northern polar sea of liquid hydrocarbons about 70 degrees north. And the probe would descend by parachute, like the Huygens probe of 2005. During the 6 hours of descent, it will analyze the atmosphere and then splash down the liquid surface. The plutonium-powered craft's principal function is to sample and analyze the organics on the surface for a period of about 3 to 6 months. This would be first floating exploration of an extraterrestrial sea. Or, here's a sneak peek of a possible future mission to Saturn's moon Titan. NASA has showcased their vision of a robotic submersible that could explore the moon's vast lakes of liquid methane and ethane. Studying Titan is thought to be a look back in time at an embryonic Earth, only a lot colder. Titan is the only moon in the solar system to have a significant atmosphere, and this atmosphere possesses its own methane cycle, like Earth's water cycle. Methane exists in a liquid state, raining down on landscape laced with hydrocarbons, forming rivers, valleys, and seas. Several seas were extensively studied by NASA's Cassini spacecraft during the 127 flybys. Some of the seas average a few meters deep, whereas others have depths over 200 meters, 660 feet. The maximum depth with which Cassini's radar instruments can penetrate. So, at this year's Innovative Advanced Concepts, that's the NIAC Symposium, a Titan submarine concept was showcased by NASA Glen's COMPASS team and research from Applied Research Lab. Envisioned as a possible mission to Titan's largest sea, Kraken Mar, the autonomous submersible would be designed to make a 90-day, 200-kilometer, that's 1,250-mile, voyage exploring the depths of this vast and very alien marine environment. As it would spend long periods under the methane sea surface, it would have to be powered by a radioisotope generator, a source that converts the heat produced by radioactive pellets into electricity. Much like the missions that are currently exploring space, like Cassini and Mars rover Curiosity. Communicating with Earth would not be possible while it's on a dive, so it would need to make regular stops coming back up to the surface so that the orbiter could get the data, collect the data, and then beam it back to us at Earth. But the Kraken Mar is not a tranquil lake for gentle sailing. It's known for choppy waves, and there's evidence of tides, all contributing to the challenge. Many of the engineering challenges have already been encountered when designing terrestrial submarines, robotic and crewed. But these seas will be extremely cold, estimated to be close to the freezing point of methane. That's 90 Kelvin or negative 298 degrees Fahrenheit. A special piston-driven propulsion system will be needed. We need to develop that to be used as a ballast, for example. And there's the Kraken. Well, no, there's not the Kraken, but this study is just that, a study. But the possibility of sending us another submersible robot to another world, unprecedented, totally awesome. And it's not really clear at this stage what the mission's science would focus on, though it might be interesting to sample the chemicals at different lengths of the Kraken Mare. Or, how about a relocatable lander that could explore the hazy skies of Saturn's intriguing moon, Titan, according to one mission proposal, as the 8-bladed whirlybird that travels across the moon. It could investigate some of the potentially habitable sites on the Saturn satellite, where methane and ethane fall from the skies and flow as rivers and lakes. The lander-size instrument known as Dragonfly would take advantage of Titan's low gravity and thick atmosphere to visit multiple sites over several years. Moving from one promising site to the next, recharging between the brief flights. Pretty awesome, right? There are a lot of possibilities, and Titan seems to be the place to go. So, yes, I've read all about NASA's budget as a proposed budget by the current administration, and I know that there are some possibilities that lead to cuts on some projects that I've shown here today that I personally want, and I believe Congress really wants too. So, you know, we'll see what happens, but until Congress says it's not happening, it's happening still. In the meantime, I put together some different launch material for you, so let's take a look at that. And then when you've stuck around for that and you've watched every bit of it and you say, wow, that is kind of cool, tune in for next week. And when we leave the solar system. And what do you need to lead the solar system? Well, maybe warp drive. Next time we'll take a look at that. And we'll take a look at where we're going. We'll plan it out, and we'll plan on visiting a whole bunch of things that we've only just discovered, like the TRAPPIST system. Pretty cool, right? So, I'll see you next time when space-time continues.
5, 4, 3, 2, 1, 0, +1, +2,
S200 ignited,
+3,
vehicle liftoff.
+4, plus 5, plus 6, plus 7, plus 8, normal, plus 9, plus 10
Just
seconds.
heard the announcement, lift off normal.
Before touching, plus 15 seconds,
10 seconds, plus 9,
plus 20 seconds, plus 15 performance normal, plus 25 seconds, plus 30 seconds,
moving